In this lesson, we're going to look at variability. We're going to look at four measures of variability, namely the range, the interquartile range, the variance, and the standard deviation. And we're going to look at which one to use when. We're going to look at how to calculate variability for group data, and we're also going to look at how to find these values using your calculator. First of all, let's just remind ourselves on how to find the mean, which we've looked at in a previous lesson. So imagine two groups of people were asked, how many hours per week do you exercise? And the people in group A gave the following responses. The first person said they exercised for 4 hours, the second person said they exercised for 5 hours, and so on. And let's imagine the people in group B gave these responses. So the first person in group B said they exercised for 0 hours, the next person in group B said they exercised for 3 hours, and so on. And then let's calculate the mean for group A. So reminder, to find the mean, we add up all the values and divide by how many there are. So in this case, the mean for group A is 4. And let's do the same thing for group B. And here we find that the mean is also 4. So the mean number of hours per week that they exercise is the same for both groups. However, the data don't really look very similar, because if you look at group B, the values are more spread out. They vary more. So as well as calculating an average, it would make sense that we should calculate some measure of how much the data are spread out or how much they vary. There are several measures of variability. We're going to look at 4 of them: the range, the interquartile range, the variance, and the standard deviation. So first of all, let's have a look at the range. Now the formula for the range is the highest value take away the lowest value. So let's look at our data from before. These were the values for group A. So we can see that the highest value for group A was 5 and the lowest value for group A was 3. So the difference between them is 2. These were the values for group B. Have a go at calculating the range for group B. So for group B, you should have done 10 minus 0, which is 10. Now let's have a look at the interquartile range. To find the interquartile range, you put the data in ascending order and you calculate the value 3/4 of the way, take away the value 1/4 of the way. We often use IQR to represent interquartile range, and the value 3/4 of the way is often called the upper quartile, and the value 1/4 of the way is often called the lower quartile. And the notation we often use is the symbol for upper quartile is Q3 and the symbol for lower quartile is Q1. So if we want to find the value 1/4 of the way, we do n plus 1, where n is the number of observations, and divide by 4. If we want the value 3/4 of the way, we do n plus 1 over 4 and times by 3. It's kind of similar to when we found the median before, if you remember. To find the median, you do n plus 1 and then halve it. So that's a similar method we're doing here. So let's have a look at the data we had before. So these are the values for group A. So first of all, I've put them now in order from smallest to the largest. And we want the value 1/4 of the way and 3/4 of the way. So to get the value of 1/4 of a way, we do 7 plus 1 over 4, because there are 7 observations, which gives us 2. So we want the second value. So our second value, 1, 2, is 3. That's our lower quartile. To find the upper quartile, we do 7 plus 1 over 4 times 3. That gives us 6. So our upper quartile is the 6th value. 1, 2, 3, 4, 5, 6. So our 6th value is a 5. So therefore, the interquartile range is 5 take away 3, which is 2. Those are the observations from group B. I've arranged them in ascending order. So can you now please find the interquartile range for group B? So you should have found that, again, the lower quartile is the second value, which in this case is 1. The upper quartile, again, is the 6th value, which in this case is 7. So therefore, the interquartile range is 7 take away 1, which is 6 for group B. So we've looked at the range and the interquartile range, but which one should we use? Well, most of the time we use the interquartile range. It's preferable because it's unaffected by outliers or extreme values. So let's just have a look back again at group A. The range we found was 2 and the interquartile range we found was 2. Now, if, let's say, the last person in group A had given an answer of 50 hours instead of 5, so group A was this, let's imagine, then when we calculate the range, we find it's 47 and the interquartile range is still 2. Now the interquartile range is better because the response of 50, it might have been a typo or a lie, or even if the 50 was true, the interquartile range, the value of 2, is much more representative of the whole group. The range of 47 isn't representative of the whole group really. So most of the time interquartile range is used. We don't really use the range very often. Now the third measure of variability we're going to look at is called the variance. This is the formula for the variance. So let's have a look a little bit closer at what we need to calculate. So it says sigma x squared. That means we have to add up the x squareds. Now x is just the observations. So we have to square each of our values and then add them up. We then need to take away n lots of x bar squared. Now x bar is the mean. So we have to square the mean and we have to multiply it by n, where n is the number of observations. And then finally, we need to divide by n minus 1. So let's look at calculating this for group A. So we first of all have to square all the values and add them up. So in this case, we get 116. We also need to work out the mean. We did that on an earlier slide. So therefore, we can stick those values into our formula. So the formula says we do the sum of the x squareds, take away n lots of the mean squared. So we substitute 116 in here, 4 in here for the mean, and there are 7 observations. So n is 7, so we substitute 7 here and here. And when we calculate all of that, we end up with 0.667. So that is the variance for group A. Those are the observations for group B, have a go at calculating the variance for group B. So the sum of x squared is 184. The mean is 4. Substituting the values into our formula, we get that. So the variance in this case is 12. And the fourth measure of variability we're going to look at is called the standard deviation. Now the standard deviation is simply the square root of the variance. So we just need to square root the formula we had on the last slide. So S, the standard deviation, is found by doing this calculation here. So let's work through calculating the standard deviation for the group A data. So we just do very similar calculations, or the same calculations as the previous slide, then we just square root it at the end. So we just end up with 0.816 hours. So that is the standard deviation for group A. Have a go at finding the standard deviation for group B. So to find the standard deviation, we do this calculation here, which gives us 3.46 hours. Now, standard deviation is used quite often. So it's a term you will often hear. So how would we interpret the standard deviation? Well, the rough interpretation of the standard deviation is it tells you how much the data vary from the mean on average. So what we're roughly saying is, for group A, these values varied on average about 0.8 hours from the mean. Remember, the mean was 4. And for group B, this varied a lot more. The answers varied about 3.46 hours on average from the mean, which was 4. So we've looked at 4 different types of variability: the range, the interquartile range, the variance, and the standard deviation. Well, most of the time we use the standard deviation. But sometimes we will use the interquartile range. And these are the occasions when we might use the interquartile range. If there are some outliers, or if it is an ordinal variable. Now, we met ordinal variables earlier. An ordinal variable is one which is a category answer, and they can be put in order. Now let's have a look at how to find measures of variability from grouped data. So first of all, let's have a look at how we'd find the interquartile range if the data is grouped. What we do is we use the cumulative frequency. You may remember we've done this kind of thing before when we were finding the median from grouped data. So let's imagine we had these data here. So this was the number of times students attended a particular class. So one student attended 3 times, one student attended 6 times, 3 students attended 8 times, 6 students attended 9 times, and 8 students attended 10 times. We may want to find the interquartile range for how many times they attended. So what we do is we'd create an extra row called the cumulative frequency. And a reminder, the cumulative frequency is simply a running total of the frequency. So we started off with 1, then we add 1 to give 2, then we add 3, and so on. Now, we know that the lower quartile is going to be the n plus 1 over 4th value. So n here is 19. There are 19 students altogether. 19 plus 1 over 4 is 5. So we know the lower quartile is the 5th value. So what we need to do is we need to go along this bottom row until we get to the 5th person. So we know the first person is in group 1, is in the first group. The second person is in this group, and the third, fourth, and 5th people are in this group. So the 5th person is in this group, so that's where the lower quartile is. So it has the value of 8. Now let's find the upper quartile. The upper quartile, n plus 1 times 3/4, which gives us 15. So we want to find where the 15th person is. So again, going along our bottom row, the 5th person was there. So the 6th, 7th, 8th, 9th, 10th, and 11th people are there. The 12th, 13th, 14th, 15th, 16th, etc. people are in this group. So therefore, the 15th person is in that group. And that has a value of 10. So our upper quartile is 10. So the interquartile range is 10 take away 8, which is 2. Now let's have a look at how to find the standard deviation from grouped data. So if the data are grouped in a frequency table, then our formula is adjusted slightly. This is the same formula as before, except for there's an extra f here. Apart from that, everything else is the same. So let's work through an example using that formula. So in this example, these are our values of x and these are our frequencies. So to find the standard deviation of that, what our formula says we have to do is we have to multiply f by x squared for each of them and then add them up. So this column gives us f times x squared. So for the first value, we do 17 times 0 squared, gives us 0. We then do 12 times 1 squared, gives us 12. 23 times 2 squared gives us 92. 37 times 3 squared gives us 333. And 18 times 4 squared gives us 288. We add all of those up and we get 725. So 725 is going to go in this part of the formula. The next part of the formula is n multiplied by the mean squared. So we need to find the mean. So we did this in a previous lesson. When you want to find the mean of grouped data, you have to do f times x, add them all up, and divide by n, and you find n by adding up the frequencies. So in this case, we end up with the mean of 2.252. So we now substitute 725 and 2.252 into this formula. And we find out that the standard deviation is 1.31. Now we've looked at how to calculate the standard deviation going through the formula, but there is a handy button on the calculator which you can use to find the standard deviation. This is very useful for checking your answer. So let's have a look at how we'd use our calculator to find the standard deviation for this example here. In this example, the salaries of people were recorded. So one person had a salary of 17.5 thousand, 4 people had a salary of 22.5 thousand, 10 people had a salary of 27.5 thousand, and so on. We want to find the standard deviation for these data. So I'm going to talk through the instructions for using the Casio FX83 calculator. Most calculators will have similar menus. So the first thing you need to do is go into the setup menu and select stat and frequency on, and that turns the table facility on, so you can enter the data in group data. You then press mode and stat and 1 var, and that takes you to the data entry screen. You can then enter the data using the arrow keys and pressing equals after each entry. So you do 17.5 equals, then 1 equals, then 22.5 equals, then 4 equals, and so on to enter the data. Once you have entered the data, you then press the AC button, and that takes you out of data entry screen. And you could then find the standard deviation by pressing Shift, Stat, Var, and S. So in this case, it will tell you the standard deviation is 4.81. As I mentioned, if you have a different make of calculator, you may have to choose a slightly different order of buttons. You should use your instruction manual to just check how you would do that for your specific calculator. And finally, let's have a look at how we'd calculate the standard deviation if some of the answers were a range of numbers. So, for example, in this table here, students were asked how many times they'd posted on Facebook. 4 students said 0 times, 8 students said 1 to 5, 13 students said 6 to 10, and so on. So the issue we have here is 1 to 5, 6 to 10, etc. aren't numbers. So what we do is we just use the mid value for each group. We did a similar thing in a previous lesson when we were working out the means. So the mid value of 1 to 5 is 3, the mid value of 6 to 10 is 8, and so on. And then we simply just use the same formula we had before for our standard deviation. It is worth noting that when you do find the standard deviation, when you take the mid value, it will only be an approximation, because this value here, 3, is assuming that everyone who gave the answer to 1 to 5 meant 3, but clearly they may well not have done. Similarly here, every value here, 6 to 10, we've assumed was 8, which probably isn't true. So bear in mind that whenever you calculate a standard deviation, it will be an approximation by this method. So to recap, we've looked at 4 different measures of variability: the range, the interquartile range, the variance, and the standard deviation. We've said that most of the time the standard deviation is the best one to use. The exception to that is if there are some extreme outliers, it's sometimes best to use the interquartile range, or if the data or the variable is an ordinal variable, then we have to use the interquartile range. Then finally, we looked at an adjustment to the formula if the data are grouped. And we also looked at how to use our calculator to just obtain the standard deviation just using the S button.